All right, we're starting unit 2.3, which is proportional relationships and graphs. So you should have the slideshow open on your Pear Decks. Today, by the end of the class period, you should be able to say, so we're going to take the proportional relationships that we talked about last week, and now we're just going to be looking at them in the graph and determining if they are proportional or not. Again, here's your homework for the week. This is already the 5th time that you see it. 7th grade, K2, K3, K4. All right, here we go. It says graphing proportional relationships. We're going to start with the story problem. Here's the story problem. Most shower heads that were manufactured before 1994 use 5 gallons of water for every minute. So 1 minute, 5 gallons of water would come out. 2 minutes, another 5 gallons. 3 minutes, another 5 gallons, and so on and so on and so on. So if you took a 20-minute shower, that's a lot of water that you were wasting. Now we discovered that we did a Google search, and we discovered that now shower heads have something in them to where only 2.5 gallons of water come out. It's a water restrictor. It's a limit. So now as much water doesn't come out as it used to. So they want to know, is the relationship between the number of gallons of water and the number of minutes, is it proportional relationship? So we could just find out by what we did last week. Last week, we did, I want you should have your slide open. You can look at my slide too. Last week, we found that if we do a table, we could say 1 to 5. We did our table going this direction. And it's not writing. I'm running out of ink. This is my X, this is my Y. So when 1 minute passes by, we have used up 5 gallons of water. So 2 minutes would be what? 10 gallons of water. So I want you to fill out this table right here on your own slide. I want you to fill it out. Write your name at the top of your slide. You can type it in or do whatever, but write your name so I can tell who's doing what. You can put your initials, that's fine. And I want you to fill out this table. So it would be 1 to 5, 2 to 10, 3 to 15, something to 35, and 10 to what? 10 to 50. So 7 to 35. Can we find, let's go by what we did last week. Can we find the constant of proportionality? What was the constant? What is K? How do we find K? Y divided by X. Y divided by X. Or you could ask yourself, how do you get from X to Y? Times 5. So our constant is 5. Can we write an equation from this? Y is equal to, what is K? 5. And then we put our X. This is our equation. This is our constant. There's our table. You should have filled out the table already. All right, based on this information, is it proportional? Yes. You could check it from here. How do you get from 1 to 2? Times 2. How do you get from 5 to 10? Times 2. So yes, it is proportional. Yes, it is proportional. Then we have letter C. I haven't done it yet. On your way back. Letter C says, write the data in the table as ordered pairs. Time, comma, water. I'm going to erase this and let's talk about ordered pairs. What is an ordered pair? No, an ordered pair we use on our coordinate plane. This is a coordinate plane right here. Remember, an ordered pair comes from x, x, comma, y, and it has to be in the parentheses. X going across your coordinate plane, y going up and down. So can we make our coordinate plane, if this is time is x, water is y, I want you to fill out letter C. Go ahead and fill out letter C. Yes. All right, so we are writing letter C. We have to write our coordinates. So we have 1, 5, 2, 10, 3, 15, 7, 35, 10, 50. Now we are going to take our ordered pairs. These are your ordered pairs, and we're going to graph it. Ms. Hank says it. So we have 1, 5. To graph 1, 5, look at me. I'm going to go across 1 and up 5. Well, notice the tick marks for the water are by 5s. The numbers are by 10s. The tick marks are by 5s. So my first point is going to be on the very first square of 1 and 5. My second point will be 2 and 10. My third point will be 3 and 15. My next point will be 7 and 35. What do I notice about these 10 and 15? They're going up. Are they making a straight line? Look, guys, I'm using my line feature. You all have one too. Yes, you do. On your Pear Deck slide, you have a line feature. Now I want you to ask, I want you to answer something else before you start. What happens if you use the shower for 0 minutes? How much water are you going to use? Zero. Zero. So I want you to include 0, 0 on your graph. All right, I'm going to push pause so y'all can do that right now. So once you graph it, I want you to have noticed that if you use 0, if you use the shower for 0 minutes, you use 0 gallons. So here's your two things. Here's your two things. How to tell if a graph is proportional. Number one, does it go through 0, 0? What do we call that place? That location, 0, 0. The origin. Close. So you're going to ask yourself, does it go through the origin? Does this one go through the origin? Yes, because if there's 0 amount of minutes, you're going to use 0 amount of gallons of water. Does it go through origin? And question 2, you're going to ask yourself, does it make a straight line? If the answer to these is yes, then your graph is proportional. Straight line. Does it make a straight line? Does it go through the origin? Those two questions are what you're going to be asking to decide if something is proportional, if a graph is proportional or not. That's it. From here, you can do your homework now. But let's do some more examples. Look at the next slide. The next slide says, a house cleaning company charges $45 per hour. Is this a proportional relationship. So they've already graphed it for you. For 1 hour, it's $45. For 2 hours, it's $90. 335. They've made your coordinates from there, X and Y. They graphed it. And now let's follow the two questions. Does it go through the origin? That means if the company works 0 hours, how much are they going to charge you? 0. So the origin would be 0, 0. So does it go through the origin? Yes. Does it make a straight line? Yes. So the answer to this is yes for both. Good job. That means I'm doing my job. Let's do one that's not that easy. It says, Jared rents shoes for $6 to go bowling. So that's an amount he has to pay. Then for every game that he plays, he has to pay $5. So for one game, he's paying 11. For 2 games, he's paying 16. For 3, he's paying 21. I want you to make your coordinates and graph it quickly. You don't rent new shoes for every game. No, he's not. All right, so if we are graphing this, we're saying 1 is 11. So at 1, I'm going to have 11 right here. My 2 is going to be 16, which is right above here. My 3 is going to be 21. My 4 is going to be 26. There's my dots. My 0 is going to be 6 because even for 0 games, they're still renting for $6. So my first one is 0, 6. Now, if I put my line, that's my straight line. Is it proportional? Is it going through 0, 0? No. Is it a straight line? Yes. But even if it's a straight line, if the answer is no to one of those questions, then no, it is not proportional. So it is not proportional because the line does not go through the origin. Not proportional because line does not go through, I wish I could write in cursive, origin. All right, that's what you should have written. Let's go to the next one. Actually, we're going to stop right here. I'm gonna show you what to do for homework, how homework is going to work. Let's go ahead and finish this example, this slideshow. So this one, they want to know the relationship between time in minutes and the number of miles Damon runs. So without looking, we don't know what the story is. But just by looking at the graph, we're going to take the graph and we're going to analyze the graph, and we're going to be able to tell how many miles he's running and the amount of time given. So can we tell how much if X is, let's do our X and Y. The first dot is at 10. When X is 10, that means for 10 minutes, how many miles does he run? 1. When X is 10, Y is 1. What's the next one they show us? At 20 minutes. 20 minutes, how many did he do? At 20 minutes, he did 2 miles. How about 30 minutes? 3 miles. Can we find our constant rate of change, our constant of proportionality? Can we find what k is? Remember we said k is equal to y divided by x. What is it? 10. 10, right? Or you could have, it's divided by 10. It's not times 10. So it's not 10. What do we say dividing by 10, we said, is the same as multiplying by the reciprocal. What's the reciprocal? 1/10. The flip, remember? 1/10. In a decimal, 0.1. So in 1 minute, he would have done 1/10 of a mile. In 2 minutes, 2/10 of a mile. 3 minutes, 3/10 of a mile. 10 minutes, 1 whole mile. Do you see where that's coming from? So we took information from the graph to be able to make our constant. Can we put it into an equation? Y is equal to, what is K? The 1/10 X. There's our equation. So we went from a graph to a table to an equation. Can we tell a story from here? Yes, we can tell a story. Damon runs 10 for 10 minutes he runs 1 mile. For 20 minutes he runs 2 miles. We can tell our story from here just by looking at the graph, just by looking at the coordinates of this graph. The coordinates to here are 10, 1. The coordinates to here are 30, 3. Learn to read the coordinates. If you're having trouble with that, there's an iExcel for that. Let's go ahead and stop here so that we can go over the homework that is going to be due. We are doing K2, which we've already done, finding the constant rate of change. K3, look at what you're going to do for K3. You're going to graph it and then let us know, is it proportional or not? Look at how we're going to graph it. Pay attention, guys. It says, what did I do? Oh, I changed tabs. Stop. How do I change?